Hello everyone. Today I will be going over how to scrape all the UFC fighter related data for this UFC website with Python. My goal is to automatically get into this UFC stats website and extract all the meaningful fight information inside these event links. To do this, I will leverage a technique known as web scraping using Python. So what is web scraping? Well, according to Google, it is a technique that uses automated software such as bots or crawlers to extract data from websites like text and links, and it extracts this information using the underlying HTML. Now, although creating a quote-unquote bot sounds complicated, Python does this relatively easy with a single line of code by leveraging powerful libraries like requests and Selenium. The first step for web scraping with Python is understanding which bot library to use for your specific need. Regardless of the bot library you use to talk to the website, you will also need to use the beautiful soup library to more easily extract or quote-unquote scrape the HTML code. We can manually access the HTML code by right-clicking on the page and clicking on Inspect at the bottom. This brings up a window on the side where you can easily see all the tags and all the underlying HTML code that was used by the software engineers to build this website. These texts in purple enclosed by the less than and greater than symbols represent the HTML tags, and we will use these tags to extract the information we need. A bit more on this later. First, we have to determine what bot library to use. You use the requests library when you don't need to interact directly with the web page, and a simple HTTP request of the URL will provide you with the HTML you need. You use the Selenium library when you need to interact with the web page, which changes the underlying HTML in order to extract the information of interest by performing tasks like clicking, typing, hovering, waiting, and much more. And getting familiar with the website of interest is the best way to figure out which bot library you should use. Upon an initial inspection of this page, I see that I need to click on the name of the event to see the results for all the fights for that event. And this is the data I want. I want the name of the fighter, who won, how, the weight class, etc. Back to the home page, I can see that this page only shows me the most recent 24 events, and I need to click on the number 2 to display the next 24 events, or I can click on this all button and display all the events in a single page. So your natural intuition might tell you that you need to use Selenium to perform the web scraping for this page. And you certainly can, but it is not the most efficient approach because you don't actually need to click the all button from the home page to show all the events if you send a simple HTTP request to this URL that ends in page equals all. And you can bypass clicking on the event links if you first save the URLs for each event and then send a simple HTTP request to those saved URLs. Therefore, I can get everything I need by using only simple HTTP requests and no clicking. Okay, so enough talk. Let's open up a Python editor and start coding this up so you can see what I'm talking about. I will use the Spider IDE for this tutorial, but you are free to use Jupyter Notebook, VS Code, or any other IDE of your choice. I will start by importing the request library, which already comes pre-installed, and I will also import the beautiful soup library, which doesn't come pre-installed. I can run these two lines of code with the F9 key shortcut. Now, if you don't already have beautiful soup installed, you can go into your console and type pip install beautiful soup 4, and it should install successfully. As you can see, I already have it installed, so it outputs this message. The first thing I want to do is connect to the UFC webpage and extract all the page information. So response equals request dot get with the URL entry will save all the web page information from this URL, ending in page equals all. When I run this line, I don't get any immediate errors, so that's good. Now, if I print the response variable, I see an output that says response 200. This is good because it means we actually were able to get a message back from the website. If I print response.content, this shows the simple text version of the HTML content. We can see that this format is not easy to read, and by these \ends and the quote at the very bottom sort of indicates that this format is not easy to work with. This is where beautiful soup comes in. I can use beautiful soup to convert this ugly content into a useful BS4 variable I will call soup, which will equal beautiful soup, and in parentheses, the first entry will be response.content, and the second entry will be html.parser in quotes. This will ensure the proper conversion of the simple text. After running this line, I can then run the soup variable and see that the format has now been cleaned up, and more importantly, this is now a beautiful soup element, which means I can now leverage certain methods to search for specific tags in this HTML soup. To find the tags of interest, I have to go back to the web page and inspect it in greater detail now. This is one of the elements I am interested in, so I will click on it to pinpoint its tag information. With a little bit of hovering, I can quickly tell that each row in this table appears to have the same TR tag and class name. The TR tag is a table row tag, and class is an attribute of that tag. So I will copy this class name and use it to get all the TR tags with this specific class name. I will set table rows equal to soup.find_all with first entry TR in quotes, comma, class underscore equals the class name. This gets me all the TR tags with this class name and returns it as a list. It is always good to check if we didn't accidentally pick up extra tags that we did not want. When I run this, I notice that the text associated to this tag says name/date and location. If we inspect the HTML a bit, we can see that this header has the same class name as the other rows. And same goes for this empty row. This upcoming event has a slightly different name, so it won't get picked up. I'll double check this by printing out the second element in table_rows, which will have the index position of 1. As expected, this tag has no text. Finally, the third element in the list has the text Edwards versus Brady, which is the first tag of interest for me. I can go back to the web page HTML to do a bit more digging. I can click on these subtags to reveal more information. I can see that the hyperlink is inside an anchor tag, also known as an A tag, and the link is placed inside the href attribute, which stands for hyperref text. I will create a for loop to loop through all the TR tags and extract these hyperlinks and start the loop at index 2 and have it go up to the length of the list table_rows. For each iteration, I want the variable event_link to equal table rows with I in brackets dot find A. The find method does not return a list like find_all, but rather it returns the first A tag. The event_link variable holds the entire A tag, which has text as well, but I just want the hyperlink text that is contained in the href. To do this, I will use the get method with input href. I can run this for loop with a print statement first to make sure nothing breaks. Perfect. I can see that only links are being printed and they are all strings. I will create this event list UFC_events_URL to hold the URLs as we go through each iteration of the for loop. And I will change this print statement to an append statement, which will append the empty list with the URLs at each iteration. And I wanted this to be events, plural. Great. Now if I run the for loop and print the UFC events URL list, I see that I get exactly what I expected. A list with only URL string elements, which are the unique URLs for each UFC event as of this week. So the next step is to go into these URLs and extract all the data for each UFC event. Starting from the stats homepage, I can click on the most recent completed event to inspect it further. Here we see there is a lot of data, and I will be extracting all the useful information. That includes the UFC event name, date, and location, along with all this fight-specific data. My goal is to store all this data into a well-structured data frame for future analysis. A data frame is just a Python variable that has rows and columns, just like an Excel spreadsheet. To initialize my data frame, I have to first create a dictionary which will hold the column names I want in my data frame. You initialize the dictionary with curly brackets, and the entries are known as key value pairs. We then separate the pairs with a comma inside brackets. The key goes on the left of a colon in quotes, and the value goes on the right. Here, the keys will represent the column names I want for my future data frame. The key helps identify the pair, so the key on the left should be unique, and the values will be their first entries. These entries are simply serving as a placeholder for now. I expect most of my data frame columns to only hold text, so that is why I am putting just a dash in quotes. However, there are 5 columns that I want to create with numeric values, and I will go into detail as to why later. For now, I will just place a 0 inside the list entry for these pairs. I will create a variable fighter_data and use the pandas variable to convert the dictionary into a data frame. But I need to import the pandas library first by typing import pandas as PD at the top and running it. And PD just serves as a shortcut to avoid typing out the word pandas every time I access a function from this library. The data frame function from pandas converts the dictionary into a data frame. And when we click on the fighter data variable, we see that we do get indeed a nice table. Okay, so now that I have a basically empty data frame, I want to start filling in the rows with fight data. So I'll create a for loop to send a request message to each URL and extract the HTML as we did before, using the get method from the requests library. We can see that when I is 0, these 2 lines of code are used to connect to the most recent completed UFC event, which is uniquely identified by its URL. As before, I will use the beautiful soup function to extract the HTML from this URL, and I will print the soup variable to make sure everything looks good. Now going back to the web page, I'm going to start by extracting this information at the very top. I can inspect this event name just like before. After some hovering, I can see that the event name is located in a span tag with this class name, which I will also copy for later use. I can also hit Command F on Mac or Control F on Windows to search for other instances of this class name within the HTML side window. By searching the class name, I see there is only one such class. Therefore, I will create the variable event_title to hold the span tag information with this class name. And if I run and print this variable, I see that it is indeed a tag element and contains the event name text inside of it. Now, to extract the text from within a beautiful soup tag, there are 2 methods we can use. The first one is the text method, which extracts all plain text from inside a tag, and the result is now a string variable, as indicated by the quotes. However, the extra spacing also gets picked up. We can use the strip method, which is now a string method, not a beautiful soup method, to remove the unnecessary spacing from the beginning and the end of the string. A second way of getting the same result is by using the get_text method from Beautiful Soup with the entry strip equals true. For this example, the output using the 2 techniques is the same. However, the get_text method is technically removing all unnecessary spacing in the string, not just the beginning and the end. And this will come in handy later on. So I will stick to the second technique for all my text extractions moving forward. Okay, so now that I got the event name properly extracted, I want to move on to extracting the event date and location. After a bit of hovering, I can see that this information is a bit more hidden inside this div tag. So I can click on the arrow next to the tags to show more information. When I hover over this li tag, also known as a list tag, I can see that the date information is highlighted. This indicates that I am looking at the most refined tag, which is what I want. There is also another list tag right underneath this one with the same class name, which clearly contains the location information. I will double click on this first one to get a better idea of the formatting, and simultaneously copy the class name for later use. I can see that the word date is in the first item in the list, and March 22nd, 2025 is the second item in the list. The I tag is an italic tag, which is meant to convert the word date into italics. This clearly gets overridden somewhere since the word date shows up in bold and capital letters. But we don't have to worry about that since we only care about how the text looks like in the HTML, not the web page. Okay, so now I have all the insight I need to extract both the date and location information from the HTML. This date underscore location variable is going to be a list that holds the two li tags with this class name. If I run and print this variable, I can see that I do indeed only pick up the tags for the date and location. I can isolate this first li tag and print it to reveal something interesting. If I were to use the first text extraction technique, I would end up with unnecessary spacing in the middle of my string, which I do not want. Fortunately, the second technique does remove the extra spacing, and that is why I prefer to use the get underscore text method just to be safe. Now I could just save this string as it is, but I just want the actual date, so I have to take a few extra steps to do that. I will start by creating an empty dictionary which I will use to hold the word date and the actual date as key value pairs. I will perform the key and value separation with a for loop, since I want this process to be repeated for the location information as well. So, for each tag in the date underscore location variable, I want to first extract the title only, and in the first iteration of the loop, it will be the word date with a colon. And this string is conveniently located in the italic tag, or the I tag. I will set the variable title underscore text equal to tag.findI, which goes into the li tag and pulls only the information from the first I tag. But notice if I run this line and print title underscore text, I see it is still in a tag format. So I have to make sure to use the get underscore text method at the end to simultaneously extract the text and remove the extra spacing. Great. This all underscore text variable will be what I showed earlier. It will hold all the text from the li tag. But I only want the stuff after the colon. This is where the dictionary comes in. I will make the key to be title underscore text and its corresponding value to be all underscore text without the date and colon. So I will use the replace method, which is another string method, to replace the first part with an empty string. Now if I run this for loop and print the dictionary event underscore lock, I see that the dictionary now has meaningful key value pairs. Okay, so now that we extracted the information outside the table, it is time to extract the information that is inside the fight table and start saving it all into our data frame. After a bit of hovering, I can see that all the rows are inside a tr tag and all have the same class name. This is similar to the table in the home page. So I will simply copy this class name to extract all these tr tags and place them inside this variable fight underscore table. I will also print out the first tag element in this list to check that I didn't accidentally pick up the header again. Fortunately, that is not the case here because I can see the string 1 minute 39, the number 4, and the word guillotine choke, which we saw were associated to the first fight in the table. Therefore, I can safely loop through every tr tag in the fight underscore table variable and know that I will only be extracting the fight related information. Now, I want to start every iteration in this for loop by saving the event information into my data frame first. I will initiate a row counter outside of my first for loop to let my data frame know what row index to save the data to. I want to store every fight data into a separate row, and I will use the lock method to do just that. The lock method is a data frame method that locates the row index, JJ, and the column with name, event, and we will set this equal to the variable event underscore title. This way, I am ensuring that every fight in this URL has the same event name. We can see that when the counter JJ equals 0, this line of code places the Edwards versus Brady event in the first row of the event column. I will do a similar thing to save the date information, but remember that this information is within a dictionary, so I have to use the dictionary key date with a colon to extract its corresponding value. A quick inspection of our fight underscore data variable shows us that we saved the date correctly. And now I can repeat the same step for the location. To extract the information for each tr tag, I have to find and inspect only one of the tr tags in the HTML code in detail, since they will all have the same format. Looking at this first fight row, I can see that within the tr tag, The cells or columns are separated by TD tags, also known as table data tags, where not all of the TD tags have the same class name. However, I can see that there are exactly 10 TD tags and 10 columns in the table, which means that I can get away with not specifying the class name in the find_all method. So I will set TDS equal to tr.find_all with input TD to extract the TD tags from this tr variable. And because the variable tr is the looping variable, it is technically not created until I run the for loop. So I will simply define it in the console as the first tr tag in my fight_table list. Now if I run this line and print this TDS variable, I can see that the last TD tag in this list contains the time information, which is what I expected. And if I save the first tag into the variable WL and print it, I see that the word win shows up in this tag, which is also what I expected. I will use the get_text method to extract the text, but making sure not to forget the input strip equals true. I am going to be a bit picky here and use the method upper to turn the letters into uppercase letters to resemble the web page. Next, I want to look at the second TD tag, which contains the fighter names. I can either inspect the data here or on the web page, and I typically prefer the web page. When I hover over these names in the HTML window, I can see that each name is inside a p tag or paragraph tag, which is inside the second TD tag. I also see there is a hyperlink associated to these names, but we will only extract the text since I already showed you how to extract the URLs at the beginning of this video. Therefore, I will refine my fighters variable to only contain the p tags within this second TD tag. And if I print it, I can see that the only text inside each p tag is indeed the fighter's name. So I will save the information from the first p tag into my data frame in the column fighter_A, and the information from the second p tag into the column fighter_B, all within the same row because this is all information from a single fight. I realized that I saved the word win into a variable WL and not the data frame. So I will go back and save it into the WL column inside the data frame. I will run this entire chunk of code and make sure everything's saved properly. I can see that the location information didn't get saved in the position I expected, and that is because of the lowercase l. This is a clear example as to why it is usually good practice to run the entire script and not small pieces of code. But for teaching purposes, it is nice to see exactly what is happening at each line. So I will run the entire code, but make sure that I only run the script for a small subset of the URL, say the first 5, or better yet, just the first one. And there we go, we get exactly what we wanted. Okay, now going back to the web page, I can inspect the remaining columns of this first fight, and I can see that all the columns with plain text have the same format as the second column. The top and bottom text are separated by p tags. Now for the weight class column, on the other hand, this is a little different. Although it looks like there are two words here, I can see that the word welterweight is in a p tag as expected, but the word perf, which represents a performance bonus, is an image, and it is located in an img tag within the first p tag and not a separate one. So I will handle this one a bit differently than the others. I will save the rest of the fight data into the data frame using the same code I used for the names of the fighters, except for the weight class column, and for time's sake, I will just cut ahead and skip all the typing. Okay, so now that almost all of the columns in my data frame are defined, I have to update the variable JJ because if I don't, this for loop will just keep overwriting the first row. After the first fight data is saved, I want the row index to increase by 1, which will essentially create a new row on the following loop and save the next fight there. Now, if I run this script, I can see that my current data frame has all the fights from the most recent event, Brady versus Edwards, where every row is a different fight. But we are still missing the last bit of information that can be extracted from the weight class column. So we have to return to the UFC webpage one more time. For this event, I can see that this performance of the night bonus is just one of 4 possible bonuses a fighter can get. For example, there is also a KO or knockout of the night bonus, a submission of the night bonus, or just fight of the night bonus, where this one is given to both fighters and not just the winner. Another thing I have to take into consideration is that a main event fight can also be for a championship belt, which is not the case here, since those are typically reserved for pay-per-view. But I can go back to the events page and scroll down to UFC 307, for example, where I know that Alex Pereira defended his light heavyweight belt and both fighters got the fight of the night bonus. And all of this information will be found in this weight class column. When I inspect the fight bonus image, I can see that the URL is in an SRC attribute rather than an href attribute because they don't want us actually accessing this URL when clicking on the image. And I see that the URL has a meaningful name where it ends in /fight.png. And I can see that this is the same naming convention for the belt image. The image URL here ends in /belt.png. If I inspect the rest of the bonuses, I can also see that the images for these end in a similar way. perf.png, sub.png, and ko.png. So I will use this newfound insight to properly extract the information from the weight class column. I will save the weight class text directly into the data frame in the standard way. And I will save all the image tags into the variable img_list. We saw that there were 5 different image names that were meaningful that we could extract from the image tags. So I will save those names into a dictionary as the keys and set their value entries to be 0, where 0 will indicate no bonus or no title fight. And this will usually be the case for most fights, which means that for most fights, the img_list variable will be empty. However, if the img_list variable is not empty, that means that either the fight was a title fight or the winner got a bonus, or both. And we can overwrite the corresponding value in the dictionary inside this if statement. To do this, I will initiate a for loop that will loop through each image tag and extract the src attribute using the get method and store it into the variable src. If I run the entire script and print the variable src, I can see that there was definitely someone who got a performance bonus. Now, to update the values for the dictionary keys I created, I need to make sure I use the exact same key names. This src variable does have the key name at the end, but it also has a lot of extra text that I do not want. So to extract the text that matches the key here, I need to use the split method with a / entry. This splits the string at every / and returns a list, as we can see here. And within this list, I just want the last entry. So I use the index -1 to only get that last entry. And I will save it all into a variable called key. I will update the key value pair in my dictionary to have value equal to 1 for this specific key. Now, all that is left to do is to place the updated dictionary values into the data frame and run the script. After running the entire script, I can look at my data frame to see if this code worked. And it did. I can see that only performance bonuses were given at this event. If I wanted to stop here, I could just save the data frame fight_data as a CSV file using the to_CSV method, where the first entry is the name of the file with .csv extension, along with the file path. I will call my file UFC_events_data and save it into my downloads folder. I can also add the entry index equals false so that the first column that contains the indices does not get saved. And if I run this last line, I can see that it worked. The CSV file is now in my downloads folder. But I wanted to scrape all the fights for all the UFC events, so I have to change the range of my first for loop from 1 to the length of the variable UFC_events_URL. I should also make sure to track the progress of my code, and I can use the time library to do that. The perf_counter method from the time library creates a timestamp when this line is ran, and I can store it into a variable start_time. I'll repeat this process at the end of the for loop and take the difference of the two timestamps, and I will store this difference in the variable execution_time. The difference will be captured in seconds, so I'll divide the difference by 60 seconds and round it to 2 decimal places so that I could print the runtime in minutes. I'll print the runtime using an F string, which simply allows me to insert a variable inside curly brackets in the middle of some string. I'll do the same inside the for loop to track the completion of each iteration. Now I will run the entire script and return when it is done. But before I cut away, I would like to give a big shout out to Tommy from MMA On Point, who actually inspired this video. He performed a really cool analysis to determine what age fighters start to decline in their performance. And if you haven't watched it already, I definitely recommend it. However, he manually scraped over 7,000 fights by hand and explained how excruciatingly painful that process was. So kudos to him for sticking through it. But that is why I made this video, to show a real-world application of web scraping and show you how having the right knowledge and tools at your disposal can save you a lot of time and even increase your earning potential. So if you are breaking your head trying to make progress on a project or class related to math, statistics, or data science, and feel that watching videos just isn't doing it for you, then feel free to reach out to us for a consultation. We offer expert tutoring and consulting services for students and professionals at all academic levels, including doctoral researchers. And I'll put our contact information in the description so you'll know where to find us. Alright, so returning back to the code, I can see that it took just under 6 minutes to run through 725 UFC events. I can also see that there were a total of 8,094 fights within all those events. And if I open the data frame, I can see that everything looks good. And the data is now ready for us to perform exploratory data analysis. But that is a topic for another video. Overall, I hope you enjoyed this video and found it helpful. Thanks for watching.